Yes, I think I made many of you. Oh, sorry. The answer should be error in D because I have computed the error in D. Sorry for that small mistake. But I hope all of you understood what is to be done in this question. Okay. If it was error in C, none of these are correct because none of the options are given. But delta D by D is what I wanted to ask because error in C is already given in the question. So it was a misprint by my on my side. The correct answer should be error in D. All right. So for today's class, what we are going to do, we are going to cover motion in one dimension which is also called as motion in a straight line. Okay. For those of you who are saying yesterday's class is not uploaded, it's already uploaded. Please go check our YouTube channel. You will see it there. Okay. Motion in one dimension is what we call as motion in a straight line. Got it. So motion in a straight line, what we are going to do is first understand different definitions. Guys, for those of you who are saying significant figures, I'll teach you significant figures after a while. Motion in one dimension does not require that. That's something I will do separately. Definitions, sorry. Then equations of motion. Equations and then graphs. These are the three things that are important here. Let's start with the first thing, definitions. So now in motion in one dimension, we use the different terms that are used to describe motion. There are three terms that are frequently used to describe motion. First is this. Let me move it up. Sorry. Displacement. Displacement is basically the change of position, change of the position of an object when it undergoes motion, right? So this is a vector quantity, denotes change in position. So let me give you an example. So let's say there is an object that's initially here at position A, it moves to position B. Initially it is at this position, later it's at this position. So final position minus initial position. Basically RB minus RA is the displacement. Right? Although I've drawn vectors here in this lesson, basically we will only do things that are important from the point of view of motion in one dimension. Okay. RB is basically nothing but the distance from the origin minus distance of O from the origin and distance of B from the origin and distance of A from the origin, right? So that is denoted as displacement. Displacement has the same units as distance. Displacement is a length quantity. It has same dimensions as distance. All right. So this is basically distance. Okay. Now, let me ask you a quick question to make sure that you understand the concept very clearly. Okay. So here's going to be a question. What is the displacement of the object when it goes from A to B in the given figure? Let's do, let me give you the options first. Okay. R root 2, R by root 2, and 2R. So basically the object is at A, moves quarter of a circle, goes to B, the circle has a radius of R. Okay, let me launch a poll for you. You can also write your answers in the chat box. If the poll is not visible, you can write your answers in the chat box. I want you to tell me what is the displacement in this case. In fact, I just want the magnitude of the displacement. Okay, I can see some answers B, B, 2R, B, B. I'm going to wait for more answers. Just answer it in the chat if poll is not visible, that's okay. Okay, B, D. So I can see a lot of B's and D's. That's what I can see. Let's see how to do this problem. So basically, displacement is change in the position. Here you can very clearly see that the object was initially at A, then it moves to B. So you have to essentially find out this length. Now you can see that this length is the hypotenuse of a right triangle with R and R as its sides. So displacement AB is nothing but root of R square plus R square, which is nothing but R root 2, which is option B. So the correct answer is B. We can also, there's a question by Adil, can we put L equal to R theta? No, you cannot put L equal to R theta because R theta denotes this length. This is R theta, right? So if you are asked the distance, you can use L equal to R theta. If you do if you basically are asked the displacement, you have to basically join it using a straight line and then use geometry to find out the answer. Okay. So hope Adil, your misconception is clear. You cannot use R theta because R theta gives you the distance. That was going to be my next question, but since you have asked it, I'm not going to ask that question. Okay. So this is the basic idea of displacement that you need to understand. Whenever you basically move from one place to another, when there is a difference in position, you have to join the initial position and the final position with a straight line, and that will basically give you the value of displacement. Okay, so I hope this question was clear. Let me move on. So we defined displacement initially, right? Displacement is referred to by the quantity x. Okay. Now, after it is referred to by the quantity x, there are some other quantities also that are defined. The next quantity that is defined is velocity. Velocity is defined as, rate of change of displacement. It's called, also denoted by delta x, which is the change in displacement, by delta t, which is the change in time. So rate of change of displacement is the velocity. Velocities is a vector quantity again. Let me just make sure that all of you note that down. Velocity is a vector quantity and its analogous scalar quantity is speed. It's very similar to speed, but speed is a scalar quantity. The units of both are meters per second, right? Velocity also is in meters per second and speed is also in meters per second. The dimensions are the same. Now there are some different kinds of velocity that you need to understand. The first one is instantaneous velocity. Okay. So let's say you're driving a car. If you're driving a car at different points, let's say I stay in Mumbai. There's lots of traffic on Mumbai roads. Now there is no traffic because there are no vehicles outside. But usually on a normal day, there are lots of vehicles outside. Now what happens when there are lots of vehicles is that you cannot go at the same speed throughout. Let's say I'm trying to drive at 60 kilometers per hour. Okay. Or let's say I'm trying to drive at 10 meters per second or 20 meters per second. I cannot be at 20 meters per second at every point of time, right? For some time when there is less traffic, I can go at 40 meters per second. For some time, I can go at 20 meters per second. For some time, I'll go probably at 5 meters per second. So now, but if someone asks me what is the, if I, let's say I travel from home to office, right? At every different point of time. So let's say for some distance, I might be 10 meters per second. For some distance, I might be 5 meters per second. Then there might be less traffic. I might go at 40 meters per second. So this is my home sweet home. And this is my workplace. Okay. For some distance, I am at 5 meters per second again, then 20 meters per second, and so on. Okay. Now, if someone asks me, let's say I reach office and someone asks me, what speed did you drive at today? I cannot give that person one answer. Okay. Because the reality is that at every point I had a different speed. Now, if someone asks me at 10:45, what was your speed? Correct. So let's say I started at 10. This was my speed at 10:15. This was my speed at 10:30. This was my speed at 10:45. This was my speed at 11. This was my speed at 11:30. This was my speed at 11:45. If someone asks me what is my speed at 10:45, someone gives me an exact speed, then I know that 40 is that speed. So that speed at a particular time is called speed. In fact, I should use the word velocity, but in a straight line, velocity and speed are the same. So velocity at a particular instant is called instantaneous velocity, right? Instantaneous velocity, as the name suggests, is pick one instant at that precise second, whatever is the time, is what is called the instantaneous velocity at that point of time. But now if I go to office and someone asks me what was your speed during traveling, I cannot give that person a single answer. So what do I do in that case? I take an average. I take the average velocity. Average velocity is defined as total displacement upon total time taken. Okay. So let me give you some context. In this case, you can see here that it has taken me roughly around, let's say I reach office at 12. It took me 2 hours to reach office. And let's say the distance is 10 kilometers, right? So my average velocity would be 10 kilometers by 2 hours, which is 5 kilometers per hour, right? Remember that this is the formula for average velocity. Total displacement upon total time. Now there is a common misconception that students do a lot in average velocity. I'm now going to give you a question to understand the misconception. Okay. You can note this down for a minute. Anyway, I'm going to make these notes all available to you like yesterday's class. So don't worry if you have missed something. I'm just going to move ahead in the interest of time. Sorry. Okay. So let's do a quick question. Okay. The question is, a car travels from A to B, which is, it covers half the distance, sorry, 1/3 the distance. Give me a second. I want to change the numbers a bit. It covers half the distance at 10 meters per second and the second half at 20 meters per second. Okay. What is, I'm first going to write the options because otherwise all of you start guessing immediately. Let me write the options. So option 1 is 15. What is the average velocity? Okay, I'm going to explain this. If you have not understood, I'll explain this concept using this problem. So don't worry. So 15 meters per second is the average velocity. That's option 1, right? Option 2 is 13.3 meters per second. Option 3 is 10 meters per second. And option B is 17 meters per second. Okay. So tell me the correct answer by writing in the chat. Poll probably is not working right now. Let's use the chat to give me the correct answer. Some of you are giving B, some of you are giving A, most of you are giving B, which means you all know how to do this problem, which is very good. Okay, perfect. I'm going to repeat this concept through this problem. Okay. So now the correct answer here is 13.3 meters per second. Now let's see why. One common mistake that people make is when different velocities are given. I saw someone write in chat also, right? So what is happening here is there is point A, there is point B going from here to here, right? So what is happening here is half the distance it is traveling at 10 meters per second. The other half it's traveling at 20 meters per second. Now the mistake people make is if someone says average velocities, they just take the average of the velocities, which is wrong, right? So remember the key concept is average velocity is not the average of the velocities. It is not the average. You don't do 10 plus 20 upon 2. If you do 10 plus 20 upon 2, you will get 15 meters per second, which is the wrong answer. Okay. Average velocity, we just defined a bit way back, is total displacement upon total time. That is the definition of average velocity. Now, if you look at this problem, let's assume that the total displacement is x. So this will be x by 2 and this will also be x by 2. So the total displacement is x by 2 plus x by 2. That's the numerator. The denominator is the total time. So time taken would be time taken for the first part plus time taken for the second part. So that would be x by 2 divided by 10, which is distance of the first part by speed of the first part, plus x by 2 divided by 20. Okay. So this turns out to be x upon 20 plus x upon 40. Now x gets cancelled. So this becomes 1 upon 1 by 20 plus 1 by 40, which upon simplification turns out to be 13.33 meters per second. Okay. So that's the correct way to find out average velocity. You never take, remember this is a common mistake even I used to make when I used to study. Average velocity is not average of velocities. Okay. So a quick formula for if there are only two sections, right? If for some part it is, for equal parts it's V1, V2, right? And this is X1, X2. So you have to basically do X1 plus X2 upon X1 upon V1 plus X2 upon V2. That's the way you always compute average velocity. I hope this is clear. Give me a yes if you understood this problem. This is a very, very common question that is asked because this seems very simple, but still people make mistakes. Got it. Understood. So let's now move on to the next part. Now, velocity, we now studied there are two parts to velocity, instantaneous velocity and average velocity. Now velocity can be graphically represented. Okay, velocity because it is delta x upon delta t. Okay, so if I take a displacement time graph, let's take a displacement time graph. Okay, let's now try to represent both average velocity and instantaneous velocity in this graph. So let me take this graph. So let's say this is the graph. Okay, now let's say something moves from point A to point B. So let's say this is the initial position, this is the final position. Now let's say it takes this path and comes here. Now if I want to find out displacement, displacement is nothing but this length. If this is displacement, this is time, right? This was the initial displacement, this is the final displacement. So the change in displacement is this is delta x, and the change in time is this is change in time. So the velocity, average velocity, is nothing but delta x by delta t, correct? So the average velocity is, if I say O, is BO upon AO, correct? So which is nothing but delta x upon delta t. So the average velocity is the slope of the line segment joining initial and final positions. That is what we call as the average velocity. Now, what is the instantaneous velocity? Instantaneous velocity, what basically happens is the line segment starts coming down. We keep reducing this delta t. So for instantaneous velocity, if you take a point, just take the tangent. Okay, slope of, so again the graph is always a displacement time graph. The slope of tangent at that point is the instantaneous velocity, right? Now there are lots of questions asked on this, right? Because in graphs there is not a lot of computation to do. You just have to understand the concept. Now slopes are of three types. Slopes are either positive, negative, or zero. Okay, a slope is positive if the direction of the tangent, the angle it makes, is like this. Okay, if theta is less than 90 degree, then slope is positive. Slope is negative if the angle, if the line is the other side, 90 degree greater than theta, theta is between 90 and 180 degree. Slope is zero if it's flat, like this. If it's like this, delta x upon delta t is zero. So whenever there is a flat line, that the tangent is flat, that means the velocity is zero. So these are the three things I want you to remember, because graphically a lot of times questions are asked on the nature of the instantaneous velocity. Now, the more the pull slope in the positive direction, tan theta keeps increasing from 0 to 90, the more the velocity, right? The more positive the velocity. So let's now do a quick problem based on this. Again, these notes are available, so don't worry about this. For those of you who are not able to hear me, the voice is perfectly fine because I can hear it on my other device. There must be a problem with your internet connection. Just make sure that you resolve that. Let me now give you a quick question on this. Okay, so there is a particle whose, I'm showing you that particle's displacement time curve. A particle's displacement time curve graph is as follows. Okay, this is what it looks like. So let's take this is point A, point B, point C, point D. Okay, the maximum and minimum instantaneous velocity is at, so this is displacement and time. I'm giving you options. Okay, I've given you 5 options here. Okay, the max for this graph, which place will have the maximum instantaneous velocity and minimum instantaneous velocity respectively. Here are the options in front of you. I can see a lot of C's, lot of D's, lot of couple of E's, but majority of the answers seem to be C. All right, let's now proceed to figure out how to solve this. So we know that instantaneous velocity is defined as the slope of the tangent. Okay, now let's draw the tangent, right? A is like this, B is slightly higher, C is even higher, and D is slightly lesser, right? So now here the maximum clearly is C, because all the slopes are positive and C is clearly the maximum. Now the minimum you can't really figure out, because from the figure, unless I give you angles, you can't say that D and A, which of them is lesser, right? So the maximum is clearly C, but the minimum can't be figured out, which means the correct answer is E, none. So here purposefully I didn't give angles, because you in an exam, unless the angles are given, you cannot make an assumption on which one of them is larger or smaller. Okay, if I however gave you A is the origin, then the answer is correct. The answer should be C is the maximum and A is the minimum. Here you can't really figure it out. It seems like D is the minimum, right? You can say that, but from the figure, unless you have a protractor and measure the angles, you can't really say it, which is why the safer option to go with is E. However, all of you seem to have understood the concept of maximum. C is clearly the maximum because the graph is rising, and hence the maximum is definitely C. All right. So that basically is the concept of instantaneous velocity. Okay. Now let's move on to the last quantity, which is acceleration. Acceleration is defined as rate of change of velocity. So acceleration is defined as rate of change of velocity, which is nothing but delta V upon delta T. The unit of acceleration is meters per second square, meters per second per second. So now delta V by delta T is there. Now again on a velocity time graph, slope of the curve on VT graph denotes the acceleration. Okay, so acceleration when the slope is positive, this means velocity is increasing. When the slope is negative, this means velocity is decreasing, which means it's retardation. So this is an example of retardation. If the slope is 0, velocity is constant. It's not 0. Slope is 0 does not mean velocity is 0. Velocity is constant, which means it's uniform motion. Okay. So the slopes of the acceleration time graph tell us very, very important things about what is the type of motion. Positive slope of the VT, not the acceleration type graph, of the positive slope of the VT graph basically tells us that it is increasing velocity. Negative slope tells us decreasing velocity, and zero slope tells us that it's uniform motion. All right. So this was the definition of the three different types of quantities. Most of the definitions that we studied were word definitions or graphical definitions. Okay. This is again instantaneous acceleration. Okay. You're right, Sudhanma. This is instantaneous acceleration. Okay. Now, algebraically also, all of you need to understand how these are related to each other. Now, displacement is referred to by the word x. Velocity is referred to by v, and acceleration is referred to by a. Right? Now, based on this, there are some algebraic questions that are also asked. I'm going to teach you the theory to this. Then we have lots of problems that we'll do. The first thing is v is dx upon dt. So if you are ever given an equation for the displacement of a body, you just differentiate it, you will get the velocity. For instance, if x is 4t plus t cube, then v is d by dt of 4t plus t cube. Now all of you know that the differentiation of t raised to n is nt raised to n minus 1. Right? This you must have studied. If you don't, just remember differentiation of t raised to n is nt raised to n minus 1. So the velocity is, there are two parts to this. 4 into t raised to 1 minus 1, 1t raised to 1 minus 1 plus 3t raised to 3 minus 2. So the velocity is 4t raised to 0 plus 3t, 3 minus 1, sorry, square. T raised to 0 is 1. So this is 4 plus 3t square. Okay. So that is basically the expression for velocity if displacement is given. Okay. Now if someone asks you what is the velocity at t equal to 1 second, you can say that v at 1 is 4 plus 3 into 1 square, which is 4 plus 3, which is 7 meters per second. So these type of questions are also frequently asked, where you're given an expression for x, 4t plus t cube, or some similar expression. From that x, you can find out an expression for v, and from there you can find out the velocity at different instances. Okay, so let us do a quick question based on this. Again, I'm going to give you some time to note this down. All right. Notes are anyway going to be available. The displacement of a body is given as x equals 3t square minus 4t. What is its initial velocity? A 0, B 3, C 6, and D Okay, please give me an answer for this based on just what we studied. You're given an equation for displacement, and based on this I want you to answer what its initial velocity would be. Now you have to think about what do you mean by initial velocity. I can see some D's, some zeros. So people are either answering 0 or D, or so A or D. That's what seems to be the conflict here. People who are answering without thinking, you'll understand what mistake you're making. Okay, let's basically now do this. Now, whenever you're given x is 3t square minus 4t, right? First thing is, the question asked is initial velocity, not initial displacement. This is displacement. If I asked you initial displacement, then the correct answer is 0, because you just substitute t equal to 0. Initial always means t equal to 0, right? Initial always means t equal to 0. Now, initial displacement is 0, but that's not what is asked in the question. What is asked is initial velocity. So first we have to have a formula for the velocity. We know that v is dx upon dt, which is d by dt of 3t square minus 4t, and hence this is 6t minus 4. Okay, the correct answer here, v at 0 is 6 into 0 minus 4, which is actually minus 4 meters per second, which is none of the correct answers, which is option E, which many of you even said minus 4. So the initial velocity is minus 4 meters per second. So remember that if you are asked the initial, so many people think that initial velocity is always 0. No, initial velocity is not always 0. You from the displacement, you find out the initial velocity, formula for velocity, put t equal to 0. Initial always means t equal to 0, because time is always 0 at the beginning. Okay, and that on substitution, whatever is the value you get will be the value of the initial velocity. Okay, so this is an example. Let me now give you one more concept and then give you one more example. Similarly, acceleration is dv upon dt. Okay, Anaga has a question. When a body starts from rest, velocity will be 0. Exactly, correct. So when a body starts from rest, v at t equal to 0, that velocity at t equal to 0 must be 0, right? So the given formula that I gave, the body is not starting from rest. Okay. Now acceleration is a is dv by dt. So let me now take the same example. 3t square, x is 3t square minus 4t. If I want to find out the acceleration, first I will find v. V was 60 minus 4. Then I will find out a. A is d of 60 minus 4 by dt. So which is 6. So this motion has an acceleration of 6 meters per second square. Okay, so that's the way you will compute acceleration. Okay, so I hope this is also very clear to you. Algebraically, how do you find out acceleration, displacement, and velocity? Let me now give you one more problem to judge your understanding of this. Which of these particles show uniform motion? Okay, v equal to 3t square, v equal to 2t square plus 6, v equal to 6 meters per second, and d v equal to 2t cube minus 6t square. Again, this is a very simple question if you understand what it is. Clearly, the answer has to be C, which many of you are giving 6 meters per second, right? Uniform motion means acceleration has to be 0 or v has to be constant. Now, in each of these, V is not constant because depends on time. V is not constant, depends on time. V is not constant, depends on time. And hence, these three are not uniform motion. But on the third one, V is constant, 6 meters per second. So it depends on time. Let me now change the question for you. The question is the same. Which of these is uniform motion? Same question, but let me change the options a bit. X equal to 3t square, x equal to 2t plus 5, x equal to 3t cube, and x equal to, sorry, this is 2t raised to 4 plus 5, 5t plus 4. Now I've given xt. I've not given you the regular ones. I've given you xt. Tell me which of them is uniform motion. B and D are not the same. B is this, I'm writing this again. 2t raised to 4 plus 5. Okay, I think many of you are getting this. The correct answer is D. So here, again, here displacement is given. So first you have to see which of them has constant velocity. X is 3t square means V is 6t. Differentiation of 3t square. This means V is 8t cube plus 5. This means V is 9t square. This means V is 5. The only constant velocity case is option D, which is V is 5, which means the correct answer is X is 5t plus 4. Well done, all of you. I hope you have understood this. So that was one part of the definitions and the different types of questions that are asked. Okay. Now, the next type of questions that are usually asked are those involving equations of motion. Okay. There are lots of things, but I'm just doing the most important things from the point of view of examinations. Let's do that first. And then in the end, we'll do lots of problems. So, motion in 1D, as I started off, basically means straight line motion. Now, there are three equations of motion that are defined for straight line motion. Now, these three equations of motion, there are some conditions on when they are valid. If acceleration is constant, if acceleration is constant, and if it's an inertial frame, and we study about inertial frame later, so don't worry about what of this. There are three equations that hold true. Okay, the symbols we use here are V is final velocity, U is initial velocity, A is the constant acceleration, S is the displacement. Okay, remember this here, S is the displacement and not distance. That's a common mistake that people make. Okay, it's the displacement. If D and T is obviously the time. Now, all of these are only valid when acceleration is constant. When acceleration is not constant, we cannot use the equations that I'm going to write. So there are three equations. First, V equals U plus AT. It says that the final velocity is the initial velocity plus acceleration into time. You've studied this a lot of times, so I'm going to go quickly. The second is V square is U square plus 2AS. The third is S is UT plus half AT square. These are called the equations of motion. But remember, this is valid only if there is constant acceleration. Do not use these equations if the acceleration is not constant. So whenever you want to find out displacement, speed, velocity, time taken, if acceleration is constant, this is what we will use. We will now see applications of some of these. There is another one for displacement in the nth second. I will do it using a problem. I am not going to use it as part of this. But since for those of you who want to know, there's one more which talks about displacement in nth second. That is S at nth. This is nothing but Sn minus Sn minus 1. Okay. Sn minus 1 is u n plus half an square minus u n minus 1 minus half a n minus 1 square. So this basically becomes u plus half a n square minus n minus 1 whole square, which is n square minus 2n plus 1. So this is nothing but S at nth is u plus half a 2n minus 1. So this is the displacement in the nth second, not in nth second, in nth seconds. So Dhanva, as a question, can we use for instantaneous acceleration? We will see using problems. Don't worry, it's a valid question. I'll come in a while to that problem. So these are the different types of equations of motions in constant acceleration. Now, the best way to understand it is by doing lots of problems. So I'm now going to give you lots of problems because that's how you will see. Let me start the first one. So there is a boy on top of a tower. Of 20 meters height. He drops a stone. If g is 10 meters per second square, time taken to hit the ground is not time taken to hit the ground. Speed at ground is 20 meters per second, 40 meters per second, 5 meters per second, and 10 meters per second. Okay, this is problem. I want you to solve this and tell me the answer to this. I can see a lot of answers. I can see a lot of A's, 1D. Come on, guys, quickly answer. Very simple problem. Very, very simple problem. I can see A's, B's, A. I think many of you are saying A, and the correct answer is in fact A. How do you do this? So very clearly, yahan pe, you know so the way to do these problems is to identify the variables given. So you have a tower, you have a boy on top, which basically has a stone. So stone's initial position is this, final position is this. Okay. So now when someone drops something, whenever you say drop, that means U is 0. Correct? Because when you're dropping, you're not going to throw. There's also a formula to this, but I'm going to go through the basics. So U is 0. So which means, and you have to find out speed at ground. You are given S, you know U, you know the acceleration. So the formula that contains V, U, G and S is V square is U square plus 2AS. So I'm just going to substitute very simply. So I want to find out V. So final velocity square is 2 into 10 into 20. So that is 400, which means V is 20 meters per second. So you can either remember the formula or remember the equations of motion and just substitute values. So the alternate formula is when for dropping. So if you have a tower H of height H, velocity at bottom is root 2h upon g, right? That is the formula for those of you who want to remember the formula. Omkar, the acceleration is not always negative. If I basically take my coordinate system like this, I can take downwards positive and upwards negative. That's up to me. So it's not always negative. We can basically just use the coordinate system according to our convenience. Anyway, in the options, basically, what I've basically done is I've given velocity. So velocity is also negative, right? But options velocities are all given positive, which is why I have taken the coordinate system in the other way. Okay. So that's how you do it. Anaga, no, your maximum height turns out to be right, but that's not the correct way to approach this formula. The correct way is when it's dropped, root 2h upon g is basically the velocity at the bottom, right? That's why I think it's very difficult to remember a lot of these formulae. Go by the 3 equations of motion, just identify which equation it is. Okay. Let's now move on to the next problem. Okay. Let me pick up a nice problem for you. So the initial velocity of a particle is 10 meters per second. Its retardation is 2 meters per second square. Okay, I'm going to first give the options, then give you the questions, because otherwise you just tell out the answers. 1 meter, 19 meter, 50 meters, and 75 meters. So the question is, distance covered in the 5th second of motion is, again, you know what formula to use because I've said 5th second. So consider the correct formula and tell me the answer to this. Let me see. I see a lot of D's, B's, A's. Again, look at the question carefully. It's not 5 seconds, it's 5th second. Answer accordingly. Satvik, the coordinate system is according to you. However you want to take it, you can take it. But just stick to one coordinate system for one question. Let me now do this problem. So here, the formula to use is Sn is, we just studied u plus half a into 2n minus 1. Okay. Now from the question, we know that Sn u is 10. A, because there is a retardation, is minus 2 meters per second. Okay. Just give me a second. And n is 5. Okay. So we are just going to use this. U is 10 plus half into minus 2 into 2 into 5 minus 1 is 9. So this is 10 minus 9, which is 1 meters per second. 1 meter. So the correct answer is A, 1 meter. Well done, all of you. Ritesh, Samiksha, Barin, Mahesh Kumar, Nitesh, all of you got this right. So this is the way you compute the distance covered in the 5th second. Let's now do more problems. Tell me yes if you want to do more problems. There are 10 more minutes left. Perfect. Let me now pick up a slightly difficult problem. Not so difficult, but I think all of you should be able to do this. All right. So this is based on an initial concept, not necessarily what we studied right now. Let me see. I'm trying to pick up the right problem for you so that it's not too difficult. Okay. So I'm going to give you a displacement time graph. Time graph of a particle. Okay, so it's going to be something like this. Okay, so displacement time graph is like this. So let's say this is C, this is D, this is E, and this is F. Okay, now the question to you is, let me give you the options also first. C, D, E, F. The question is, velocity is negative at which point? That was a very quick answer. Shreya was the first to answer. Darshan, Shreya, Krishna, Anoop. Yes, all of you are now very quick to answer. Someone by mistake, I think, answered F because C and F are next to each other in the keyboard. That's okay. Got it. So the correct answer clearly is E, because here we have seen that the slope is negative. Negative slope, and negative slope on a displacement time graph means velocity is negative. Okay. All right. Let me give you more problems. Okay. So here is a slightly tough problem. So far we have been doing really, really easy problems, but sometimes once in a while there are going to be some tough problems. So here it is. So the displacement of a particle is given by S is t cube minus 6t square plus 3t plus 4. Okay. What is its velocity when, let me not write first let me write the options, because otherwise you'll jump at the answer without reading it. When acceleration is 0. So it's a slightly tough problem, right? I wanted to do this carefully. I'm going to give you time for doing this, but do it carefully. What is the acceleration velocity when acceleration is 0? I can see some B's, some D's. Mostly the answers are B and D. Okay, let's see what the correct answer is. So again, this is not as difficult as it seems. Let's now try to see how to do this. So the way to do this is, so first you are asked what is the velocity, but we have to first find out when the acceleration is 0, right? So let's write the expressions for each of them. If S is t cube minus 3t square plus 6t square plus 3t plus 4, we know that V is ds upon dt is nothing but 3t square minus 12t plus 3. That's V. Now A is dv upon dt, which is the derivative of the velocity, is 6t minus 12. So now we know the expression for displacement, we know the expression for velocity, and we know the expression for acceleration. Now A is 0 implies 6t is 12. This means we are basically asked, this basically means you're asked what is the velocity at t equal to 2 seconds. Now let's substitute t equal to 2 seconds. The answer becomes 3 into 2 square minus 12 into 2 plus 3, which is 12 minus 24 plus 3, which is minus 9 meters per second. Well done, all of you. The correct answer is D, minus 9 meters per second, right? So this lesson does not have a lot of tough problems, but you need to get a lot of practice on this, right? That's when you will get much more familiar with what to do here, what not to do here. Okay. Let's do one more, since all of you seem to be in a good form. Let me give you a similar problem. Sorry. Motion of a particle in straight line is x equal to 8 plus 12t minus tq. Okay. Now my question is, sorry, what is the retardation when v equals 0? A 24 meter per second square, B 0, C 6 meter per second square, and D 12 meters per second square. Okay, that was a really quick answer. The question is, what is retardation when v equals 0? Okay, I think everyone seems to have got it. So basically, if x is 8 plus 12t minus t cube, so v is 12 minus 3t square. So when v is 0, this means t is 2 seconds. 3t square must be 12. Now retardation must be equal to a is minus 60, must be minus 12 meters per second square. That's the acceleration. So the retardation is minus of minus 12, which is 12 meters per second square. All right. So we are almost at the end of the class. Okay. I'm going to do a couple more problems. So there are some questions on you on what will happen to the assignments. You will get assignments beginning today. Yesterday was the first class, so I didn't give any assignments. So at the end of today's class, in fact, let me give you an assignment right away. On your chat, you will see now a file I'm attaching. Let me give that to you right away. I'm going to attach a file. Just give me a second. Okay. So you're going to get an assignment right away. I'm sorry, I sent it to only one person instead of everyone. Okay. You must now have seen, I've already created an assignment for you, which we will solve basically, which all of you have to solve before tomorrow's class, before the next, tomorrow there is no class, before the class on Monday. So that is the assignment I want all of you to solve on motion in 1D. Check. I think everyone, I can see it is given to everyone. Depending on your internet speed, you will get it. Anyway, don't worry. You will get it on your WhatsApp group as well. I can see it is given to you. You will get it on your WhatsApp group. Don't worry. Okay. See, some of you have already got it. Yes. Your internet speed might be slow, which is why it will take some time. Don't worry. Don't panic so much. All of you will get. See, for those of you who've got it, click yes. You will now see many people have received it. You will get it on your WhatsApp group. Okay. So no need to worry. The writing no and no again. See, Saif has already got it. Akshay has got it. People are getting it one by one. It's a slightly large file, which is why it will take some time. Zoom is not like WhatsApp where you'll get instant material, right? All right, got it. So that's the assignment for the next class. Also, I want to use the last, the class is not over for those of you who are saying bye. I want to use the last basically 4-5 minutes to basically explain to you what the plan is going to be. So I'm now going to share the week-wise planner for you. You're now going to see my screen. Just give me a second. I'm going to stop sharing this. Okay. So I'm going to share one more document on my screen. Tell me when you see it. I'm not shared it yet, so don't panic immediately. Just give me a second. Okay. You will now can all of you see my screen? I'm going to zoom it a bit. Give me a second. I'm trying to zoom it. It's not. Got it. Okay. So what you will get essentially at the end of today's class, all of you will basically get a timetable like this. This is being finalized. So you will basically get a timetable based on your day-wise topic and test schedule. Okay. So there is no test tomorrow, but beginning the week after, you are going to have a test. Okay. So this will basically tell you on what date, what topic is going to happen, on which subject. The timetable has already been fixed. 9 a.m. to 10:15 is physics, 10:45 to 12 is biology, and 12:30 to 1:45 is chemistry for some days and maths for some days, and 2:15 to 3:30 is maths for the other days. All 4 classes will begin today. You will get this sheet by the end of today on your WhatsApp group. Children, I want to tell you one thing. Please don't panic about if something is, you're not getting something. We will provide. We have no intention of keeping all the materials with ourselves. We will provide all of these things to you on your WhatsApp group. You just have to wait till the class is over, right? So what you will get is basically an assignment, correct? For all those who have registered for the program, you will get an assignment after every class. Solutions and answer keys will be provided for some problems. You will get this plan, and the notes for today's class will also be given to you at the end of today's class, just like we gave it at the end of yesterday's class. Okay. There will be a delay in WhatsApp. There will be some time taken because all of you are anyway sitting in class till 3:30. So you do not need to access it till 3:30. You can check it after 3:30. By the end of the day, you will get it. All right. Anyway, so that's basically the plan. You will get a very detailed planner so that all your questions on what class is going to happen, how much time we are going to give to different topics, all of them will be answered. Okay. So that's the end of today's class. It's already 10:18. You have a biology class after this at 10:45. Thank you for being here. In the next class, I will continue a bit of significant digits, and we will also basically do remaining problems in motion before moving to dynamics of motion. I hope all of you had an enjoyable class today. I hope to see you again on Monday. There is no class tomorrow. The next class will happen on Monday. So there's a 25-minute break now before your next biology class. So all of you can do whatever stretching you need to do before you finish off. Solutions for the assignments will only be given after you actually solve the assignments. Otherwise, you will just see the solutions. If you have doubts in assignments, you can post it in the WhatsApp group. Your teachers will answer them. Yes, all classes will happen here only, same link. You don't need to basically go anywhere else. This is your classroom. So for all practical purposes, the Zoom link is your classroom. This is where you have to come every day from 9 to 3:30. Okay. So that will not change. So in a while, your biology teacher Neha ma'am will come and start it. Don't worry about getting the assignment. You will get it. We are not going to take your assignments anywhere. You will get it by the end of the day. So don't worry. Check the WhatsApp group later. In the recording, we have finished recording. Let me pause recording and we will upload it.